Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here is another video in calculus, particularly on finding the derivative of functions. So I hope that you will enjoy watching this video and you will learn something, especially for the beginners. Differentiate the functions. So we have 10 exercises in this video, and these numberings are same numberings in the book by Love and Rainville. So 15, y equals 6 minus x raised to the negative 4 thirds. I differentiate this by power formula. Remember, derivative of constant is 0. And this is negative of negative of or negative 1 times negative 4 thirds x to the quantity negative 4 thirds minus 1, which is negative 7 thirds. So therefore, this is negative of quantity negative 4 thirds times x to the negative 7 thirds. So dy dx therefore is 4 thirds x to the negative 7 thirds. So by power formula. Number 16, it's also by power formula. So dy dx is equal to 6 times 2 thirds x to the negative 1 third, where negative 1 third is 2 thirds minus 1 by power formula. Then minus 3x squared. Derivative of negative x cubed is negative 3x squared. Simplifying, dy dx is 4x to the negative 1 third minus 3x squared, because 6 times 2 thirds is 4. So dy dx is 4x to the negative 1 third minus 3x squared. Number 17, this is derivative of product. So I will call the first function as u, the second as v. And remember that the derivative of product is first u, derivative of v with respect to x, plus v, derivative of u with respect to x. So this is dy dx is 1 plus x squared times negative 2. The derivative of the second function is negative 2 with respect to x. Then plus 3 minus 2x, derivative of the first is 2x. So plus quantity 3 minus 2x times 2x. Simplifying, dy dx is negative 2 minus 2x squared plus 6x minus 4x squared. Combining like terms, dy dx is negative 6x squared plus 6x minus 2. So negative 6x squared plus 6x minus 2. Number 18, it's the same, derivative of product. So I'll treat the first function as u, the second as v. So it is first x squared plus 3 times derivative of v, which is 2x minus 1. So dy dx is quantity x squared plus 3 times 2x minus 1. Derivative of x squared minus x plus 1 is 2x minus 1. Plus second, quantity x squared minus x plus 1. Derivative of x squared plus 3 is 2x. Then simplifying, dy dx is 2x cubed minus x squared plus 6x minus 3. Then for the second, we have plus 2x cubed minus 2x squared plus 2x. Then combining like terms, dy dx is 4x cubed minus 3x squared plus 8x. 6x plus 2x is 8x minus 3. So dy dx is 4x cubed minus 3x squared plus 8x minus 3. So that's it for problem 18. Problem 19 is new. This is in the form derivative of constant over variable, derivative of c over u. So the guide is the derivative of c over u is equal to negative c over u squared times du dx. This formula is by power formula, derived by power formula. So you may transform this into quantity 3x minus 2 to the negative 1 so that the derivative is negative 1 times quantity 3x minus 2 to the negative 2 times 3. Derivative of 3x minus 2 is 3. So therefore, the answer is negative 3 over quantity 3x minus 2 square. So here, if we use this, the answer is the same because du dx is 3. So negative of 1 times du dx, which is 3, all over u square all over 3x minus 2 square. So the answer is negative 3 over quantity 3x minus 2 square. So as I said, you may transform this into quantity 3x minus 2 raised to negative 1 and apply power formula, which is the technique or the process I will show for problem 20. So I'll transform this into 1 plus 2x to the negative 1, then apply power formula. So dy dx is negative 1 times quantity 1 plus 2x raised to negative 2 times 2, because derivative of 1 plus 2x is 2. Simplifying dy dx is negative 2 over 1 plus 2x to the power 2, the positive 2. So you may use this, again, this tool here, this guide, in differentiating that. So if we use this, so we have negative 1 over 1 plus 2x raised to 2 times 2. So it's the same, negative 2 over 1 plus 2x quantity square. 21, it's the same, x is 3 over quantity t squared plus 1. So I'll use this guide here. So this derivative dx dt is negative 3 over quantity t squared plus 1 square, then times derivative of t squared plus 1 with respect to t is 2t. Simplifying, dx dt is negative 6t over quantity t squared plus 1 square. 22, it's the same, so I'll use this guide again. So dy dt is equal to negative 4 over quantity 1 minus 2t cubed square. Then the derivative of 1 minus 2t cubed is negative 6t square. So times negative 6t square. Then combining, simplifying, dy dt is positive 24t square all over 1 minus 2t cubed quantity square. Then 23, y equals x over x squared minus 1. This is derivative of fraction u over v. So the guide is denominator times derivative of numerator minus numerator times derivative of denominator all over denominator square. So we use that guide. So x squared minus 1, derivative of numerator is 1. Then minus numerator, which is x, times derivative of denominator, which is 2x. So x minus x times 2x all over the square of the denominator, quantity x squared minus 1 square. So remember that that's the guide formula derived in the earlier videos for the theory and functions and techniques rather. So dy dx is x squared minus 1 minus 2x squared all over quantity x squared minus 1 squared. Since the numerator is negative x squared minus 1, so we write the final answer as negative quantity x squared plus 1 all over quantity x squared minus 1 squared. So dy dx is negative of quantity x squared plus 1 all over x squared minus 1 squared. Then lastly, number 24, y equals x squared over x plus 1. So it's the same as 23, derivative of fraction. So dy dx is denominator x plus 1 times derivative of numerator 2x. So dy dx is quantity x plus 1 times 2x. Then minus numerator x squared, derivative of denominator is just 1. So minus x squared times 1. All over denominator square, so all over quantity x plus 1 square. Simplifying the numerator, it is 2x squared plus 2x minus x squared. 2x squared plus 2x minus x squared all over quantity x plus 1 squared. So finally, the answer is x squared plus 2x all over quantity x plus 1 squared. So that's it for this video. I hope that for the viewers, you learn something, techniques in differentiating functions, the guide formulas, power formulas, derivative of basic functions are in the preceding videos, and we just applied the tools in differentiating these functions. These functions were taken from the book by Love and Rainville, Differential Integral Calculus, and the numbering would be the same for that functions. So that's it.